All right, now we've got this 8 by 8 piece of cardboard. And what we're going to do is we're going to cut out squares. And so then we're going to fold those edges up, and it'll make like a box top, and it'll have a volume. All right, so let's think about this. So if this whole length here is 8, and this whole length here is 8, and I'm going to be cutting out these squares out of the corners, right? So each of those side lengths will be x, right? Okay, so let's find out what the volume is going to be. So you know volume is length times width times height. So length, I'll just go this way. This distance here will be all of the distance 8. Subtract off these two x's. Then if I'm going to do the same thing for the width, that would give us the same, right? I would get an 8 minus 2x also. And then the height is that distance x. So it's just going to be times x. All right, I am not going to suggest we multiply this out. I'm going to say let's just simplify it a little bit. And then let's do product rule. You could multiply it all out. It's up to you. I think it's going to be easier to do this. So if I want to take the derivative, I'm going to say first d second, which is just 1, plus second, and then d first, so 2 times 8 minus 2x, times another negative 2, the derivative of the inside. So I'm just going to say, I know I'm going to be setting this equal to 0 because I want the largest volume. I'm not going to multiply this out. I'm just going to leave it. These numbers here, don't they give me a negative 4x, 8 minus 2x? Okay, so then I'm looking, I see that there's two terms and they both have an 8 minus 2x in common. So I'm going to say, let's factor out an 8 minus 2x. So then 8 minus 2x times 8 minus 2x gives me 8 minus 2x squared. 8 minus 2x times a negative 4x gives me that. So let's see what I have. 8 minus 2x, and then the inside here I get 8 minus 6x. All right, so I'm ready to set these each equal to 0. So let me bring it up top again so that I can keep in mind context, right? What I was doing, I was making this box out of this 8 by 8 piece of cardboard. Okay, so this here gives me answers of 8 minus 2x is 0, or 8 minus 6x is 0. So if I solve this, I get x is equal to 4. And if I solve this, I get x is equal to 8 over 6, or 4/3. Okay, do both of those answers make sense? Oh my goodness. If I turned up edges of 4, there would be no box. So that doesn't make sense. So this is the only one that makes sense. That gives us the maximum volume. Maximum volume is what I find. Okay, so here we go. We've got a rectangular field that's to be enclosed by a fence. And then we're going to put another piece of fence in between and break it up into 2. So let's do this. Okay, so I've got a rectangular field. And I'm going to put another piece of fence in there. Okay, so the area of the whole enclosure is 216. So area is 216. And so what I'm going to suggest is we call all of this y, and we call this distance x. So it's x times y equals 216. So what are we trying to find? We're trying to find the smallest amount of fence. So again, that's going to be the perimeter. I'm going to be wanting to set the derivative equal to 0. So it's fine. It's not really perimeter, but let me call it fence. F for fence. Fencing. How much fencing will I have? Well, I'll have 2 y's and 3 x's. Then I'm going to take this, and I don't know, I just like to solve for y, so I'm going to put that in the denominator. So then I have f is equal to 2 times 216 over x plus 3x. And then I'm going to multiply 216, times 2. 216 times 2. That gives me 432. So my fencing is 432 over x plus 3x. Okay, so now I'm ready to take the derivative. So you know this is like x to the negative 1, right? So taking the derivative, I'd get negative 432 over x squared plus a 3. So then I'm going to set that equal to 0. So I get 432 over x is equal, over x squared is equal to 3. So x squared is equal to 432 over 3. So just a totally ugly number, right? So x is equal to the square root of 432 over 3. That's the x. And if I wanted to find the y, I'd put it back in here, right? So the y would be 216 over, oh boy, that's ugly, right? But that's the answer.